There's a new source of information in the workplace. It's captured the attention of workers, supervisors, health and safety committee members, first aid personnel, fire response teams, and more. It's the Whmis Material Safety Data Sheet, an MSDS. There's safety information for everyone who works around controlled products, health effects caused by overexposure, hazard evaluation for product handling, storage, or use, protective measures, emergency procedures. It has similar information to its counterpart, the Whmis label, plus a lot more detail. Your health, even your life, can depend on it. You'll be looking at the MSDS in this segment. Its purpose, who's responsible for its content, the basic rules for its design, and some details of the information it must contain. The MSDS is the second element of the Whmis information system and is meant to supplement the alert information provided on labels. MSDSs are required reading and must be used in the development of safe work procedures. Employers must ensure workers understand the content and act on it accordingly. It's a Whmis requirement. One MSDS, however, cannot cover all the different hazards encountered from one workplace to another. Employers must transform data sheets into an active program of worker protection that may include further instructions and written work procedures. Employers will consult with the Health and Safety Committee or representative to develop these materials. Most data sheets originate with suppliers, who must provide employers with a current MSDS on or before the date of product sale. The MSDS must be available in English and French and be no more than 3 years old. Employers, in turn, must ensure up-to-date supplier MSDSs are obtained the first time a controlled product is received in the workplace. In addition, employers producing controlled products for use in the workplace must produce data sheets that meet Whmis standards. The MSDS is used to update the Whmis program as data sheet revisions become available. However, if a supplier has gone out of business or no longer produces the controlled product and is unable to provide an updated data sheet, the employer must add any new hazard information to the MSDS on the basis of the ingredients already disclosed. Information may be available, for example, through libraries, trade publications, or computer databases. All data sheets must be made available in the workplace for use by workers and health and safety committees or representatives. The data sheets must be easily accessible during each shift in a place where a worker can study the information. Data sheets may be stored on computer if the necessary steps have been taken to ensure easy access. Any design of MSDS may be adopted as long as some basic rules are followed. An MSDS must display a minimum of 9 sections of content, covering approximately 60 items of information. None of the 9 sections can be left blank. If information for a section is either not available or not applicable, then the data sheet must indicate that fact. The abbreviation NA is unacceptable where it is necessary to distinguish between the two terms. The 9 sections must have headings that cover product information, hazardous ingredients, physical data, fire and explosion hazard, reactivity data, toxicological properties, preventive measures, first aid measures, and preparation information. In this example of an acceptable data sheet format, the sequence of sections follows a natural process. Sections 1 through 3, product identification and recognition. Sections 4 through 6, risk evaluation. Section 7, preventive measures. And Section 8, first aid measures. In Section 1, product identification and use, the product identifier must be identical with the identifier on the product label. If a data sheet applies to more than one product, all label identifiers should appear on the data sheet. The Product Identification Number, or PIN, is a number which may also appear on labels and placards when dangerous goods are being transported. They are of assistance to fire departments and other emergency response personnel. The Product Use section specifies the intended product use. Other uses may pose other risks. For example, a solvent intended for degreasing tanks may pose a significant risk to workers if used as a manual cleaning agent because it evaporates easily. The manufacturer and supplier name, address, and emergency telephone number are useful for obtaining additional product information. The emergency telephone numbers should be operational for 3 years from the MSDS production date. A change in an emergency phone number will mean an MSDS update. Section 2, Hazardous Ingredients, provides information on the identity, concentration, and acute toxicity for ingredients in a controlled product. This section must disclose any ingredient which meets any one of 3 criteria. If it is present at a concentration of 0.1% or more and is classified as a cancer-causing agent or lung sensitizer, or if it could have various effects on reproduction. If the ingredient is in any other controlled product that is present at a concentration of at least 1%, or if the ingredient is included on the ingredient disclosure list and is present in a concentration equal to or more than the concentration shown on the list. The list, which contains about 1,700 entries, is used only to help with this section of the datasheet. It must never be used for classification. Copies of the list are available from regulatory agencies. The LD50 is a measure of a substance's immediate toxicity. It is the lethal dose of a substance expected to cause the death of 50% of an animal population, such as rabbits, rats, or mice, when administered into the mouth or applied to the skin. The LC50 refers to the concentration of a product in air required to do the same thing when inhaled by a test animal. The key point to remember here is that the smaller the LD or LC50 number, the more lethal the substance is. The LD50 numbers may seem abstract. To put them into perspective, consider this. A few tablespoons of a product with an LD50 number of 500 milligrams per kilogram. The cutoff for including products in Whmis in terms of immediate and serious toxic effect could kill the average person if swallowed. Section 3, Physical Data, provides a physical description of the product. Physical state identifies the product as a gas, liquid, or solid at room temperature. That's important information for understanding the difficulty of containing the product. Odor threshold indicates the minimum amount of chemical in the air that you can smell. The ability of a worker to safely recognize the presence of a product in air is determined by the odor threshold and the exposure limit for the chemical. Exposure limits are maximum limits of exposure to the substance in air. They are set by regulatory agencies to help protect workers from experiencing any ill health effects. A product has good warning properties if you can smell the product at levels below the exposure limit, and poor warning properties if you can't detect it until it is above the limit. For example, chlorine, which has an exposure limit of 1 part per million and an odor threshold of 1/10 of a part per million, has good warning properties. On the other hand, wood alcohol or methanol, which has an exposure limit of 200 parts per million, but may not be detected in air until a level of 6,000 parts per million, has poor warning properties. Odor thresholds must be used with caution when evaluating warning properties because human response to odor varies. Properly used, however, odor thresholds must be considered when selecting respiratory protection. It is dangerous to use air filtering respirators for protection against products with poor warning properties because the worker cannot detect the presence of the product at safe levels if the respirator fails. The pH of a product is one factor to consider when estimating its corrosive effects. Corrosives include acids, such as muriatic acid, and caustics, such as sodium hydroxide. The pH will be a number on the scale of 0 to 14, where 7 indicates a non-corrosive substance, such as water. Acids have pH values less than 7, and caustics have values greater than 7. Section 4, Fire and Explosion Data, provides information and procedures of particular interest to fire prevention and response personnel. A yes answer to flammability is followed by the conditions in which a product is flammable. For example, a highly flammable substance such as acetone may catch fire even in the presence of a weak source of ignition, such as a static spark, whereas a combustible substance such as kerosene may require the presence of a flame. The means of extinction item provides information on extinguishers suitable for using on the burning product. Standard firefighting agents include water, water fog, foam, carbon dioxide, and dry chemical. This section also includes special firefighting procedures for unusual product hazards. For example, some reactive metals and concentrated corrosives react dangerously with water. Compressed gas cylinders may explode unless cooled. A flash point is the minimum temperature at which a liquid will catch fire in the presence of a source of ignition. The lower the flash point, the more easily the product will ignite. Flammable liquids such as acetone have lower flash points than combustible liquids such as kerosene. Section 5, Reactivity Data, provides information on product stability and the likelihood of dangerous reaction with other chemicals. Some peroxides, azides, and chemicals used to produce plastics are chemically unstable and must be stored and handled with special precautions. Incompatible substances are those substances which react dangerously together. For example, when strong mineral acids contact caustics, large quantities of heat and mist are given off, and oxidizers, which contribute oxygen during combustion, are incompatible with flammables. Section 6, Toxicological Properties, provides information on how materials enter the body and what the short and long-term health effects are. Route of entry gives information on the ways substances can enter the body to cause harm and whether the product will cause injury to the skin or eyes. The 3 routes of entry are absorption through the skin, inhalation into the lungs, and ingestion or swallowing. For example, a substance such as free silica, found in dust from sandblasting or concrete grinding, causes harm only when it's breathed into the lungs. In contrast, many solvents can enter the body through breathing in vapors and absorption through the skin. Some solvents can injure the skin on contact. This information is useful in selecting personal protective equipment and developing first aid procedures. Effects of acute exposure summarizes the adverse health effects resulting from short-term exposure. For example, an acute exposure to carbon monoxide can, depending on the dose, quickly cause symptoms ranging from headache and dizziness to coma and death. In contrast, an acute exposure to free silica will not usually produce any immediate ill health effects and may not result in long-term health problems. However, chronic exposure to free silica in air may cause the lung disease silicosis. Chronic exposure refers to repeated exposure over a relatively long period of time. Sensitization refers to the ability of a product to cause an allergic type of reaction in a person. Isocyanates, used in some automobile paints, are an example of a group of sensitizers. Carcinogenicity describes the cancer-causing properties of the product. For example, asbestos is a carcinogen. Teratogenicity and embryotoxicity are related to injuries in offspring resulting from a pregnant female being exposed to the product. These injuries include malformation and death. Thalidomide is an example of a teratogen. Reproductive toxicity refers to effects such as sterility. The pesticide DBCP is an example of a reproductive toxin. Section 7, Preventive Measures, is based in part on the information provided in previous sections. It outlines measures to protect workers during product transportation, storage, use and disposal, as well as emergency procedures related to accidental release. Employers must adapt this information to the specific workplace hazards. Personal protective equipment provides a variety of information in the selection of gloves to avoid skin absorption, respiratory devices for inhalation hazards, eye protection, footwear, and clothing. Suppliers must ensure this information is as specific as possible to be of real use to the employer and worker. Engineering controls may cover ventilation or equipment designed to control the product at the source. Ventilation system information will distinguish between local exhaust and general ventilation systems and may provide advice on preferred fan types or duct materials. Leak and spill procedures outline protective equipment for emergency workers, control methods, and specific safety measures such as using only vacuum cleaners equipped with high-efficiency filters for use with asbestos cleanup. Waste disposal information details waste container design, Whmis identifiers, safe handling procedures, and agency contacts for disposal requirements. Handling procedures and equipment outlines precautions required during handling of the product. The procedures must be consistent with precautionary measures detailed on the product label. For example, with strong corrosives, dilute by adding to water, not by adding water to the product. Storage requirements provide essential information concerning storage temperature, separation of incompatible products, shelf life limits, and any special storage information. For example, picric acid must be stored underwater because it becomes explosive when dry. Special shipping information covers factors such as product sensitivity to shock or temperature and should provide information on TDG class and division assignments. Section 8, First Aid Measures, details immediate treatment of acute ill health effects for on-site use by first aid personnel. Separate procedures for each route of entry, such as inhalation, skin contact or absorption, or swallowing, will be necessary for most substances. Information on the early warning symptoms of adverse health effects will also be of assistance here. The MSDS preparation date, reported in Section 9, is designed to ensure compliance with the requirements for MSDSs to be current and updated every 3 years. That covers the basic introduction to material safety data sheets. The job at hand is to review the data sheet program at your workplace. Have data sheets been received for all controlled products purchased from suppliers and developed for controlled products produced in the workplace? Are data sheets filled out properly? Do they show the 9 sections of information? Do they provide information for each item? Are they less than 3 years old? Have workers been educated in the hazard information from the data sheet and any other information that applies? Are data sheets readily available to workers, and do they know where to find them? The answer to all these questions must be yes. Whmis and material safety data sheets for a safer and healthier workplace.